talk about piecewise functions. These are functions that are defined differently on different parts of the domain. So you think about what the graph would look like, but you only take a piece of it. So let's see what we mean. Here's an example. F of x equals, there's two different pieces of functions depending on what the x values are. So first of all, you think of the first one, what does the graph of f of x equal negative x look like? And we know that that is a line, and it has a slope of -1 and a y-intercept of 0. So we could put that line on there, but look at the domain. This graph, we only want the piece of it when x is less than 0. So we look where x is less than 0, and we just take that piece of the graph. Now we make an open circle on the end because it says it needs to be less than, so it doesn't equal 0. Now let's ask ourselves the question, what does the graph of x squared look like? So we're looking at the second piece now, and we know that that is a parabola that opens up, this vertex is at 0, 0. So it looks like that. But we only want a piece of that graph, the piece where x is greater than or equal to 0. So we take off the piece where x is less than 0. We color in that endpoint because it says or equal to. So it's always also where x equals 0. And there is the graph of our piecewise function. Now let's look at another example. This time we have three pieces to our piecewise function. So first, we look at the domain, and we're going to be looking from -3 to 0, and we want the piece of the line of y equals 2x plus 5, but from -3 to 0. And the easiest way to do that when you know it's a line is it's going to be a line segment if you're taking a piece of it. So we could use the endpoints. So we're going to put in -3, and when we put that in the function we get out -1, and we're going to put in 0 to the other end for this domain, and when we put 0 in that function we get out 5, and we're going to graph those endpoints and then we'll draw a line segment between them. So let's start with this first end. We're going to plot the point. When we put in -3 we got out -1, and then we're going to make it a solid dot because it does have or equal to on that side by -3. Then when we put in 0 we get out 5, so we're going to put a point there, but we're going to make it an open circle because it does not have or equal to on that end for the domain. X is less than 0. And then we're going to join them up in a line segment. So that's the piece of the graph of 2x plus 5 when x is between -3 and 0, including -3. Now let's look at the next piece, and we only look at where x equals 0. So this is just going to be a point. It's not going to be a whole bunch of places, just where x equals 0. And it says when x equals 0, the f of x equals -3. Well, we know fx is y, so we go to the place when x equals 0 and y equals -3, and we put a point. Now let's look at the next piece. We're looking when x is greater than 0, and we want to follow the line y equals -5x. So we know that that is a line that y-intercept is 0 and slope is -5. So we could start there at 0, and then we could go down 5 and over 1, draw the line. Again, an open circle on that endpoint because it doesn't have or equal to. It's just where x is greater than 0. So all of these pieces combine to make the graph of this piecewise function.